plane passing through a point and perpendicular to a vector. In this module you will learn to find the equation of a plane passing through a given point and perpendicular to a given vector. There are many planes in the space perpendicular to a given vector, but only one plane exists such that it passes through a given point as well as it is perpendicular to a given vector. Thus, a point on the plane and a perpendicular vector to the plane will specify a particular plane. Consider a plane passing through the point A whose position vector is vector A. Now consider a point P on a plane whose position vector is vector R. Now vector joining the points A and P represent the vector AP. Look at the triangle OAP. Applying triangle law of vector addition, you get vector AP is equal to vector R minus vector A. If a vector n is perpendicular to the plane, then it is perpendicular to any line on the plane. Thus, vector AP is perpendicular to vector n. This further helps us to deduce that the dot product of vector AP and vector n is 0, as cosine of 90 degrees is 0. Substituting vector R minus vector A for vector AP in the equation, vector AP dot vector n is equal to 0, you will get vector R minus vector A whole dot vector n is equal to 0. This equation represents the vector equation of the plane. Next, to obtain the equation of the plane in the Cartesian form, let us assume that coordinates of point P are x, y, z, and coordinates of point A are x1, y1, z1. The position vectors of point P and point A can be represented as a sum of vectors parallel to the three axes of rectangular coordinate system. If A1, B1, and C1 are direction ratios of vector n, then vector n can be represented as A1 I cap plus B1 j cap plus C1 k cap. Substituting the component form of vector R, vector A, and vector n in vector equation of a plane, and simplifying further, you obtain the equation A1 into x minus x1 whole plus B1 into y minus y1 whole plus C1 into z minus z1 whole is equal to 0. The equation represents the Cartesian equation of the plane through point A and perpendicular to the vector n. In this module you have learnt that the vector equation of a plane through a point whose position vector is vector A and perpendicular to the vector n is vector r minus vector A whole dot vector n is equal to 0. The Cartesian equation of a plane through a point whose coordinates are x1, y1, z1 and perpendicular to the vector n whose direction ratios are a1, b1 and c1 is a1 into x minus x1 whole plus b1 into y minus y1 whole plus c1 into z minus z1 whole is equal to 0.